Thank you. Good afternoon. Thank you for being here for this important event. I'm going to talk about water scarcity a bit today. Water scarcity is one of the greatest defining challenges of this century. Water is a critical element of political stability, economic prosperity, international security, and environmental sustainability. So we have several important cross-cutting challenges that we need to be able to address in order to deal with our water issues in the near future. How we manage our water is also an indication, in my opinion, of our expertise, our intellectual capacity, our dignity, and our ethics. Modern universities need to be able to address these challenges in a few interesting and innovative ways. They also need to be able to build students' capacity to address challenges that we have not yet completely understood. Someone mentioned this morning in the futures that do not yet exist, and we need to be able to train students for problems that we can only start to see emerging. Physicist Einstein gave us some good insight into the need to do this when he remarked that we cannot solve our problems by using the same kind of thinking we used when we created them. I think this is quite indicative for the water challenge because it is the current level of thinking that has caused some of these problems. So we certainly need to be able to develop the capacity to move beyond that to address some of these emerging issues. I believe modern universities can do this in three different critical areas, primarily by creating well-rounded and intellectually competent individuals that think independently and innovatively. But there are three more specific concepts that I want to talk a little bit about today in the context of solving the water crisis. The first is recognizing competing interests. We're going to talk about some of those today, but when you talk about complex challenges such as agriculture or energy, there are a lot of cross-cutting interests and a lot of competing interests in some of these endeavors. Second, they also need to be able to integrate complex concepts. So government, economics, biology, chemistry, ecology, all of these different integrated concepts need to come together to solve some of our greatest challenges. And third, they need to be able to solve problems in the context of uncertainty and variability. We have unprecedented levels of uncertainty, particularly in the water crisis, and also unprecedented levels of variability that we need to be able to make decisions about and solve problems regarding. Without these skills, which I believe are actually championed by liberal arts colleges and multidisciplinary programs, we will not actually be able to resolve our natural resource issues, and we will not be able to manage our natural resources effectively or efficiently in the future. Water stress is increasing greatly, so I just want to take a look at what that looks like in our era. So you can see water stress in this illustration. Water stress basically is precipitation as well as consumptive water use in addition to population. You can see some obvious population centers on here. Depending upon where you live in the world, this might not look so bad. But you can certainly see that water stress is growing in certain areas. This is actually from 2010. It hasn't changed much in the past couple of years. But in the next 30, we're actually expecting some pretty dramatic changes in this kind of water stress worldwide. This is what we expect in the next 30 years in terms of water stress. So you can certainly see some important changes here. Again, depending upon where you live in the world, there's some area for concern here as well. So let me just briefly go back to the prior. Right, this is generally what water stress looks like worldwide today. And in not so long from now, 30 years, we expect to see quite extensive water stress. Right? Some of this can be managed. Some of this is meteorological, and we'll talk about that in a couple minutes. Some of this is economic and political. Right? Some of these resources can be managed in a way to alleviate some of this water stress and some of the water scarcity issues addressed in this area. You can see some of the areas of greatest concern in terms of the change in North America and Northern Europe. And you can also see some of the areas of change in India and China, where, of course, the greatest population centers are worldwide as well. So stewarding these resources effectively is certainly going to become more critical even than it is today. Now, one of the reasons for this is that fresh water is actually a relatively scarce resource on our planet. We do arguably have enough freshwater resources to meet our needs if we manage them effectively. But we do have to break down some of the illusion of abundance of fresh water. Having lived in various parts of the country and having visited various parts of the world, I'm aware of how fortunate we are here in the Great Lakes region to have such an abundant freshwater resource at our disposal. But it does give the illusion of abundance of water in a world in which that's not actually accurate. So I'm going to take a look at that briefly in this illustration. About 97.5% of our water on the planet is salt water. That leaves 2.5% of our world's water as fresh water, and that's what we have accessible to us for our use, for human consumption, for most of our endeavors. Of that 2.5% of freshwater resources worldwide, most of that is tied up in the glaciers, which are basically our natural water storage system. That also leaves us groundwater and permafrost, but 0.4% of our freshwater is actually in surface water, which is how most of us think about our freshwater resources. That's our lakes, our rivers, and our wetlands, right, which again are 0.4% of those freshwater resources worldwide. So you can see the critical importance of stewarding these resources responsibly. Within that, you can see how the water is used, or you can see the majority of that fresh water is used for agriculture, and then the rest for industry, energy, and domestic uses. And we'll talk about those as well. So in the next generation, right, coming to grips with this reality of having 2.5% of the world's water as freshwater is something that our students will need to address, hopefully better than we have thus far. So to talk about some of the complexities in managing this vital resource, I want to focus on 3 different areas. And they're the areas that you see here as greatest use: agriculture, energy, and then I also want to talk about climate briefly because that will alter some of the dynamics. So first I want to talk a little bit about agriculture. Agriculture on the global average uses about 68% of all of the water for human endeavors. This is quite substantial. This is where I usually get questions such as, does it help if I turn the faucet off when I brush my teeth? Yes, it does. But if you really want to make an impact in water and water management worldwide, we really do have to look at agriculture. Not only is it the largest use of water consumption for human endeavors, but it's also one of the greatest polluters. Stormwater runoff, particularly from urban areas, but also from agricultural runoff through pesticides and fertilizers, is one of the greatest contributors to water contamination worldwide. So we want to take a look at that as well. In this regard, water scarcity and food security are inextricably linked. Right? Without water, obviously we can't grow food. And as demand for food increases with increasing population, we're actually going to have more demands on our water resources, particularly if we don't find better ways to use water in agriculture more efficiently. So as population grows, demand for food and water will increase. We also have several large projects that we've taken on worldwide in our system to try to manage water a little bit more effectively. Unfortunately, if you see it that way, these advances come from mistakes that we've made in the past. Some of these mistakes come from not identifying competing interests or identifying them in a way that prioritizes short-term gain. So I want to mention some of those quickly. One is the case of the Aral Sea, with which a lot of people are becoming more familiar. The Aral Sea was our 4th largest freshwater lake in the world 50 years ago. And in the modern era, we have made decisions that have led to diverting the rivers that feed that lake. We have almost entirely depleted the lake itself. Right? And this was largely for agriculture. There are competing interests here because the region really was in desperate need of economic growth, was in desperate need of some political victories as well. And large-scale agriculture, particularly for grains and cotton in the Aral Sea region, was quite a triumph economically and politically, at least in the short term. As a result, environmentally, what happened is we've basically drained the lake. In 20 years' time, we basically drained one of our largest freshwater resources in the world. This happens periodically. We also have seen this in the US, a little closer to home as well. The Colorado River was the first river in the world to fail to reach the sea as a result of human consumption patterns. The Colorado River ran from the mountains to the sea for 50 million years. And in 50 years, we basically depleted and diverted that resource to the point where most of the year, during most years, the Colorado no longer reaches the sea. And when it does, it's a very small trickle of highly toxic water. So we have learned some lessons from this. There is some optimism to be found. in the fact that we are trying to end these kinds of practices. One is the Great Lakes Compact, which I can talk about in a minute. I can see the time flying by, so I want to move on to the two others because they're quite critical. I do want to mention energy briefly, as it's one of the next largest uses of water. This is important for our purposes because it takes a lot of water to produce energy, and this is something that is often overlooked. So again, when people ask, should I turn off the tap water when I brush my teeth? Yes. What you really need to focus on is agriculture. However, it also helps to turn off the lights, which we hear for a different reason, right, for saving energy, but it actually saves as much water to turn off the lights as it does to turn off the tap when you're brushing your teeth. So I brought this illustration in of energy because you can see generally where energy use is the largest worldwide, right? And obviously you can see the high population centers on here as well as the developed regions, the economic developed regions. We used to measure the level of economic development. One of the proxies for that was energy use, right? So you can see here if you used energy use as a proxy for development, you would get a fairly good representation. Some people have been arguing that is now a failure of modernization, and we should not be measuring development by energy use, but actually by energy conservation. And I would argue the same about water. Nonetheless, it takes a tremendous amount of water to produce energy. A lot of this is because we have large-scale hydroelectric projects, hydrofracking. We have oil and coal. 30% of our energy still comes from oil, another 30% from coal. That's a very water-intensive process for extracting and also cleaning that energy source and providing it to us for our use. So with energy, we're also going to have changes in climate, which will exacerbate these other changes. Right? Climate variability will increase the frequency and severity of floods and droughts and the damage caused by those floods and droughts. Climate variation, as you know, is really an imbalance of energy. And a lot of the climate effects that we see are because of this imbalance of energy. The air and the water both store more energy, and so we see some of that energy released in some of the severe weather events. That's one important element of it. Generally, what this will look like on a global scale is that the drier areas will become drier and the wetter areas will become wetter, right? In addition to prolonged droughts in dry areas, and then floods where the water can't absorb into the dry ground, which will cause them to be much more damaging. So we want to take a look at that as one of the complicating factors that our students need to be able to address. There are very few programs in the country that actually have a climate major. We have climatologists, and we have a variety of departments that deal with these kinds of issues. But there are a host of these kinds of issues that we need multidisciplinary and liberal programs to address from a variety of different departments collaborating and cooperating to meet these challenges in the future. So this brings us to our final point of discussion. I just want to mention the capacity to make decisions in the context of uncertainty and the context of variability. I believe some of our current leadership and the institutions in which they operate have demonstrated that we're not training our leaders effectively to be able to make decisions in the context of uncertainty and variability. And as I mentioned, some of these challenges are unprecedented, and we're going to need to be able to find ways to address these and teach our students to find ways to address these as well. This brings us to another issue, which is that we need to teach students to continue to learn after they've left our institutions here. Right? If they have that desire to learn and they have the capacity to continue to learn, they will find high quality education. They will find high capacity thinkers. Hopefully they'll become some of those high capacity thinkers, and they'll come up with innovation and innovative solutions to some of these problems that we address. So again, the water crisis is a critical example, and we're running out of time, so I'd be happy to answer some questions about that. But there are other examples. Democracy is another good example, right? We need to have multidisciplinary programs that can address some of the challenges of democracy, poverty, public health, right? Food security, urbanization, patterns of consumption. These are multidisciplinary problems that need to have innovative cross-disciplinary approaches in order to make some innovative progress in these areas. Modern universities, particularly liberal and multidisciplinary programs, can address these challenges in the three ways that I mentioned: to recognize the competing interests, to integrate complex concepts and to bring a variety of different kinds of knowledge to problem solving, and third, also to learn to do problem solving and decision making in the context of uncertainty and variability. In conclusion, I just want to mention that the way we manage water, right, is again an illustration of our capacity, our expertise, our intellect, our dignity, and our ethics. And I believe liberal and multidisciplinary programs focus on these elements in a combined effort. We can do this also by building connections between complex concepts and making decisions in the context of variability. And I just want to conclude by saying it's important that we build our intellectual capacity as well as our ethical competency so that we can build an attainable and sustainable future in water. Thank you.